everybody. I'm going to do a short little lesson, and this one really will be short, about multiplying radical expressions, multiplying problems that contain square roots. How do we do this? Well, best case scenario is both numbers are under the radical. Because if both numbers are under the radical, we can multiply them together. So the square root of 2 times the square root of 3 will be the square root of 6. I'll do another quick one. The square root of 7 times the square root of 5 would be the square root of 35. No issues. What happens though when one of the things you're multiplying is outside of a radical and the other one is inside? Well, you can't do it. You can't take this and get a 6 or anything crazy like that. The answer is just 2 times the square root of 3. You cannot combine the 2 and the 3. It remains 2 times the square root of 3. All right, let's look at this, because this problem has both things happening. We have a 2 times the square root of 3. Those do not combine. So I'm going to do my distributive property, the distributive property that you've used a zillion times, but I can't do anything here. So I'm just going to write 2 square roots of 3. Remember, when you are multiplying expressions with radicals, you can combine them if they are both under the radical. The 2 is not under the radical. So that gives me 2 radical 3. Now what about 2 times 4? Well, don't make this hard. 2 and 4 are not under radicals, so we're just going to multiply them and get plus 8. Now what about this one? Okay, what about this one? Well, again, we're going to do a distributive. This is a distributive situation. Now we're going to take a radical 5 times 3. The radical 5, the 5 is under the radical, the 3 is not. So that's going to give us 3 radical 5. Please do not get a 15 out of that. You can't get 15 out of that. The 5 is under the radical, the 3 is not. What about the last part of the distributive though? Radical 5 times radical 2. Wait a minute, they're both under the radical. So I have plus, now when I do this distributive, I'm going to have the square root of 10, because it's radical 5 times radical 2, just like I had up here. Remember, radical 2 times radical 3 was radical 6. Radical 7 times radical 5 is radical 35. So this becomes radical 10. Perfect. Oh my. Oh my. Look at this. Do you know what your strategy is going to be on this problem? I hope so. Your strategy is going to be to FOIL. This is a FOIL problem. And you probably know, but in case you don't, FOIL stands for first, outside, inside, last. So it helps me multiply binomials. It's a form of distributive property, but we use FOIL, the word FOIL, to help us remember in order to do it in. So here we go. I'm going to multiply first times first. What do I get when I multiply root 3 times root 5? I get root 15. Now I'm going to do outsides. That's radical 3 times radical 2. All right, what do I get? Radical 3 times radical 2 is radical 6. What do I get on the inside? Radical 2 times radical 5 is radical 10. And my last terms, radical 2 times radical 2 is radical 4. Wait a minute. What's radical 4? It's just 2. So I have root 15 plus root 6 plus root 10 plus 2. And that is the answer to the question. Now, if you haven't watched the addition video yet, how to add and subtract radicals, please know that the only way these can be added together is if they have the same radicand, if the number under here matches. Those do not match each other, so therefore they have to remain separate. And our answer is what I have in the box. I know it's big, ugly, it's what it is. Let's try this one, same thing. Here we go. Radical 7 times radical 5. Radical 35. That's first. Now I'm going to do my outsides. Now I have a radical 7 times a 4. If you put 28, you're going to be wrong, because the 7 is under the radical, the 4 is not. So that's going to be plus 4 radical 7. All right, so I've done first times first. I've done outsides. Now I'm going to do insides. Radical 3 times radical 5. That will be, oops, minus radical 15. Do you see why it's minus? That's a negative radical 3 times a positive radical 5. And then finally, last times last. So I have a negative radical 3 times a 4. That would give me a negative 4 radical 3. Again, 4 times radical 3, I can't make that 12. The 4 is not under a radical, so it just stays 4 radical 3. Do any of these match each other? Any of those radicals match? No, they do not. And when they don't match, we can't add them up. We just leave them separate, and there we go. That's the answer to the question. So, I told you that'd be brief, so if you want to practice the practice problems, this is multiplying expressions with radicals. Have a great day.